looks different than what we've done recently, doesn't it? Somebody might say, Mr. Grimm, I feel like you could do u equals x. And my first thought is, I'm not sure why you're doing that, but let's roll with it for a second. And then they would say du is dx, and I'd be like, well, that's cool, but I feel like you didn't do anything. All you did was this. You with me? You would u sine u, yes? And I feel like that's not helpful. It's not helpful. It must not be that. You with me? It must be something different. So what I've got here, you'll see, is a product, right? And just like when we did product rule, there's a rule for what happens when you integrate a product. Now listen, not every product will be using this. For instance, watch carefully. Suppose this had been the equation instead. This one, you would do u is 3x squared. You see the difference? Yes? So then du would be 6x dx. And look, lo and behold, there I have this, yes? So you see the difference. So what I'm teaching you today is for product, but not every product. Just ones that are clearly not substitution, yes? So we know how to do substitution. So some of the substitution problems we've done in the past have had this product look to them. But some of them, like this fella, do not. You see this? So what happens when this happens, Mr. Groom? We are going to use what is referred to as integration by parts. Okay? And so let me just show you on a sheet. I'm coming back to this, but the formula looks like this, friends. It's the integral of u dv is going to be equal to u times v minus the integral of v du. Now, it's not very difficult. You're like, wait, what? Exactly. So this is what's going to happen. Okay? We were just given a function. We need to ascertain, I love that word, makes me happy. Part of that function is dv, and part of it is u. And then once I do that, I'm going to set it up like this. Well, u is this. Well, if I have u, I'm going to then go find du, just like always, yes? But if I start with dv, I'm going to have to then go and find v, aren't I? Are you with me? So the tricky part, friends, is deciding who to be your u. This is the trickiest part of this whole thing. So there is a little acrostic for you to memorize. It is this. The u should be in this order. Liate. Not really sure how you pronounce that. But logs. Logs are a bear to integrate. Nobody wants to integrate a log, but taking a derivative of a log is really easy. Are you with me? Logs are the hardest thing to antiderivative. Therefore, I for sure want to take the derivative instead. You with me? Next, inverse trig functions. I do not want to integrate arctangent, for God's sakes. It's ridiculous. So I'm going to take the derivative instead. Thank you very much. Whenever possible. Number 3 is algebraic functions. Well, what do you mean? You mean like x squared? Sure. You mean like x cubed or x to the fourth or like square root of x? Exactly. Yes, exactly. Okay. So this one is trig functions. Why would I take those last? Because any idiot can integrate a trig function. Well, most people can take the integral of cosine, yes, and get sine or whatever, right? Right? But whatever. That's not too bad. And then exponentials, because any idiot can take the, what's the antiderivative of e to the x, Mr. Grimm? I feel like it's just e to the x. Oh, that wasn't very hard. Okay? So that's the last thing I want to be my u. It's the first thing I want to be my dv. Yes? No. Let's go back and look at the one I drew over here. Oh my gosh, look. I have an algebraic function. Do you see him? And a trig function. So who should be my u? Who should be my u? My yes should be x. There you go. Okay, which means dv then should be sine of x. And remember, the dx goes with that. Okay, so let's find du, shall we? What is the derivative of x? It's just dx, right? Du is just dx, right? Or 1 dx. That makes you happy. Do you need paper? Pencil? Can I get anything for you? Cup of coffee? Can I help? All right, whatevs. So then, from whence did sine come? Who is he the derivative of?
Negative cosine.
Nice. Nice. Yeah. Now, let's go look at the recipe. The recipe says it's the integral of u dv is equal to u times v minus the integral of v du. So let's put the pieces together, shall we? What is u times v, friends? Why, it's minus x cosine x. Are you with me? Minus, because this is always a minus. You see this? That's part of the formula. The integral of v du. Oh, that's hot. I'm just filling in the blanks, yo. By the way, listen. Someone much cleverer than I, which, by the way, is not much. That's not saying a lot because I'm not that clever. Somebody much cleverer than I said, "Hey, this is kind of a thing. If we do it in this order, we can always get the correct answer." Okay, that's all we're doing. What's the question, dear?
If it's, would you say dv or du?
V d. Which one? For the which one part?
Oh,
It's v du.
oh, okay. Wait.
That's supposed to be pointy. The integral of v times du. Right? So here's v.
Oh, where's the?
There's du.
Oh, okay, I wrote that
I
wrong.
got you. You got it. You're okay. Okay. But wait, Mr. Groom. I feel like we're not done yet. No, you're right. We're not done yet. Because I still have another integral here, don't I? Negative is positive. Is that true? That true? That true? What is the antiderivative of cosine? From whence did cosine come? Sine. That's right. That's right. Plus c. That's the antiderivative, friends. That's it. That's it. Now, Amelia doesn't believe me. She thinks I'm lying to her. She is going to check me. I don't believe you, Mr. Groom. I think you're a liar. Ouch, it's hurtful, but let's go with it. Now, this is a product rule right here, the first one, isn't it?
Yeah.
So it's the derivative of the first. What is the derivative of negative x? Negative 1 cosine of x. You see this? Plus the first, so negative x, times the derivative of this, which is... What's the derivative of what's the derivative of cosine? Negative sine. Thank you. Plus, and what's the derivative of this feller? Cosine. Now wait, that's negative cosine plus x sine x plus cosine. What do you notice?
They do not cancel out.
Yeah, they do. And where do we end up? Right back where we started from. Which means we did what? We got the right answer, didn't we? Oh, we're geniuses, aren't we? You good? You okay? All right, let's do another one, shall we? Okay. It's not too bad. Yeah. All right, let's try one here. Let's do this deal. I feel like... What's the matter? What's the matter? Sine goes to... Listen, the derivative of sine is cosine. Cosine goes to minus sine. So you just go back up the chain. And listen, in my mind, I just go, okay, so I got cosine. He's the derivative of sine. Oh, so in the antiderivative, it's just sine. Done. You do you. You do you. But if I'm doing this on a sheet of paper, I just write them down thusly. I just write them down like this. Okay? This is the derivative in this order, yes? So the integrals go this order. Because they're opposites, aren't they? Right? I don't know. Whatever works for you, though. I don't know. You do you. I can't. I just work here. I don't know. Let's do that one. X e to the 2x. Oh, that's hot. Now, again, who should our u be here? The x. That's right. Golly, that's an easy one, Mr. Groom. You're right. So then our dv is e to the 2x dx. What is the antiderivative of e to the 2x? 1/2 e to the 2x. Well, Mr. Groom, you kind of used a substitution there, didn't you? I did, like I did it in my head, didn't I? Well, I didn't. Bryce did. I just went along with it. Is everyone cool with that? Right?
I don't understand what you got.
Which one?
I don't understand how you got one.
Allow me to demonstrate. Allow me to elucidate. This feels like a function in a function, yes?
Yeah.
So I did this little part in my head. Right? This is from last chapter, right?
Yeah.
So there's a half right there. So this is a half e to the u. That's it. That's all. Just did it in my old noggin. If you need paper, go jot that off to the side somewhere, yes?
Okay, so,
Yes.
what do you use the where does the dB and the v's come, like, what are those for?
What do you mean? Well, you can think of it as kind of a placeholder. We just need two functions, dear. So they chose u and v. So this right, the way you said it, you said that this is your u. The rest of this garbage is your dv, is what you're saying to me. That's what you did. And that's what you did it right, too, by the way.
Okay, so is it like just
So-
taking the other function and using it for the dB?
Kind of, yeah. That's the recipe, okay? It's always going to be that. So, u times v is 1/2 x e to the 2x minus the integral of this and this, yes? v du, right? Yeah? Well, it's a half of an x e to the 2x minus, now what's the antiderivative of e to the 2x? I wish I knew. Oh, I do. It's a half e to the 2x again, isn't it? And a half times a half is a quarter. Nice. A quarter! Hey, watch this one. This is exciting. Daniel says, make it harder for me. I says, all right. That's what I can do. Once again, who is easier to derivate and who is easier to integrate? Well, arguably they're about the same. However, when you take the derivatives of x squareds, they're going to go away eventually, yes? That'd be nice. E to the x, what's going to happen? It's just going to be e to the x, and it's lame. So watch this one here. I'm going to go, here's my uv, yes? uv minus the integral of, now be careful, it is v times du. You with me? I pulled the 6 out front because that's what I do. You want to leave it inside, you knock yourself out. Now, here we go. Watch this. Now you're like, wait, Mr. Groom, I feel like that's another product in there. Oh, crap. You mean to tell me I have to do this again? Sometimes, yes. So watch. Listen, between x and e to the x, who's going to be your u? All right. And then, of course, e to the x, and, of course, the antiderivative of e to the x is just, of course, e to the x. So wait, Mr. Grimm, you're saying the first part we're not screwing with. That's correct. We're not screwing with him. Minus 6 times, right, now let's do the integral, shall we? It's u times v. That's totes easy. X, e to the x, minus the integral of e to the x dx. X squared, e to the x, obviously. Hey, what is the antiderivative of e to the x? It's e to the x. But watch. So I'm going to take this times this is going to be negative 6x e to the x. And this times this is going to become positive 6 e to the x plus c. Yes, sir?
So what was different? So you said it's a product. What was different about the previous function?
Look at this up here. You get an x squared. The previous one had just an x. So on the previous page we had x times e to the x. So I had to do 2 integrals to get rid of it. This time I had x squared, so I'm going to have to do 3 integrals. And if I had x cubed, I bet I'd have to do, and so forth and whatnot. Yes?
That makes sense.
Yes? Okay, it's not horrible, is it? Okay. Be ready to have your mind blown slightly. Somebody took you to Oaks Park and they put you on a little merry-go-round. Okay? And you were kind of freaked out because you're like 4 years old. And like, I'm going to be standing right here. And you're like, I'm going to go around, never see you again, Grandma. And then you come around and you're like, well, there she is. Oh, there she is again. Oh, there she is again. until she gets kidnapped. Well, that's not creepy at all. That's not creepy at all. On this next one, we're going to see something very similar to that. But now, according to the rules for Liate, who should my u be? Sine. And our du should be cosine x dx. And then our dv, then, of course, is e to the x. And our v is e to the x, of course. So the formula says you need to take u times v minus the integral of v du. Now, this right here is the same basic thing, isn't it? Right? So shouldn't I set it up basically the same way over here? Let's try it, shall we? Let's do it. I mean, it's literally the same basic process. There we go. This guy I watch on the interwebs from time to time says process. It kind of drives me nuts. Okay. Now listen. The first part, you'll notice, does not change, does it? Because I didn't touch it. Now let's do the inside portion, shall we? It's u times v minus the integral of, now wait for it,
Oh no.
it's e to the x times negative sine. Do you see this? Yes?
No, I'm so.
So it's really going to end up being positive here, correct? Can you see that? Be careful. That is where you will make your mistakes, is with stupid negatives. I cannot stress that enough. That is where you'll make your mistakes. Now, shh.
You do it again.
Okay. The original equation was what? It was e to the x sine x, correct? Now, just allow me to put this side back over here. Okay. Now, I'm just going to rewrite. That's the original problem, and so far we have that it's equal to this. If you distribute the negative, you're going to get this. And distribute the negative again, you're going to get this.
So does it not become like negative cosine x?
Well, it does, and I wrote it right there. That's literally what it said. When I distribute the negative, bloop, bloop. E to the x times cosine is one thing. So it's just the whole thing is negative.
Okay.
All right, now here's my thing, friend. Look what you got. Look where we're at right now. Look at this thing right here. What is it? It's what we freaking started with.
Oh.
As promised. You're on the merry-go-round. I'm so scared. I'll never see. Oh, there's Mom. I'm so scared. Oh, there she is again. Okay. There's Mom. When you run into one of these guys, like e to the x and sine x, okay, they're clearly never going away, are they?
No.
They are going to repeat themselves. Eyes up. Be watching for it. It just happened. It should never take more than 2 times. You with me? If you're doing this like 17 times, you missed Mom. You closed your eyes every time you went by Mom. I never saw you. You never came. Well, you were doing this the whole time, you idiot. Okay, so pay attention. Pay attention. Now, how are we going to solve this? This is how we're going to solve it, friends. We're going to say plus e to the x sine x. Now, do you remember back in the day when we told you that whatever thou doest to one side, thou must also doest to the other side? How many of these guys do we have now over here?
2.
2 of them. No! Now listen, how do I solve for this? I just divide both sides by 2, don't you? That's what I do. Divide by 2. Oops. Divide by 2. Yay! Plus C. Now there's quite a few moving parts here, so one has to go make sure one doesn't get too ahead of one's self. All right, friends. I think we all agree that this is this, and this is this, yes? True dat? I think we all got that. And I feel like we got dv is equal to e to the 3x, which of course means that v is equal to 1/3 e to the 3x. Yes? And then I feel like most of us got this part right. Minus the integral of, now it's this fella times this guy here, yes? So I'm going to pull the third out front, and I'm going to pull this negative out front, yes? So it's going to be in positive 1/3 right here, yes? Okay? And then it's going to be e to the 3x sine x dx, yes? So far so good? Yay! So u is sine x again. So this is cosine x dx. dv is e to the 3x. Geez, Mr. Groom, this part's the same again. Well, of course it is. So this part, again, does not change. Gotta love that. Way less work that way. Plus 1/3, parentheses. It's this guy times this guy. So I'm going to get a 1/3 e to the 3x sine x minus an integral of, it's this guy times this guy. So I'm going to pull a 1/3 out front.
Wait, at the beginning, why'd you pull the 1/3 out?
Where at, dear?
In front of the.
Right here? Because I felt like it. By the way, could I have left it in and would it have worked? Yes. Yes, 100% yes.
Man, I was wondering because
Listen, stop. That's a good question. This is a fabulous question. Did you hear what you said? Mr. Grimm, could I have left a 1/3, like right here or right there with one of those guys? One of them, not both of them. Yes, I could have. Would it change my answer? If you don't screw it up, no, it won't change your answer a bit. Will yours look different than me as we're going through it? Partway. Will we get the same answer? Again, if we don't screw it up, we will agree on the answer. Okay? So I always pull constants out. I find them a little annoying. I just pull them out. If you leave them in, it's still... I got you. Now, let's distribute this positive 1/3 through, shall we? Just for a good time? So 1/3 e to the 3x cosine x plus 1/9 e to the 3x sine x minus 1/9 e to the 3x cosine x dx. By the way, that's negative 1/9 of mom, isn't it? Are you with me? That's negative 1/9 of mom, isn't it? Because mom is what? Mom is this person. There she is. Are you with me? Now, I don't know if I'm right yet. Let's just keep rolling and we'll see what's what. What would happen if I plus 1/9 to both sides? Well, I get 1 and 1/9, which is 10/9, last I checked. And if I don't screw it up, we, again, should be the same. Okay, so look, there they are. Mr. Grimm, I'd like to solve for mom here. So I'm going to times both sides by 9/10. Are you with me? Right? And so that would give me 3/10, I think. E to the 3x cosine x. And then it would give me plus 1/10 e to the 3x sine x. And that is the antiderivative of this guy. There it is. Mr. Graham, I don't know if I believe you. That's hurtful, but let's try it just for fun, okay? This is going to be two different product rules, yes? Let's try them. What's the derivative of e to the 3x? It's 3 e to the 3x, is it not? So it would be 9/10 e to the 3x cosine x plus 3/10 e to the 3x times negative sine. So I'm just going to make that negative. Plus, this is going to be 3/10 e to the 3x sine x plus 1/10 e to the 3x cosine x. And if you clean this mess up, this plus this is what? What's 9/10 and 1/10?
1.
1. e to the 3x cosine x. Hey, these two here do what? Son of a gun. What do you know? So this guy here is the derivative of what we said our answer was. Ergo, we must be, I guess we're right. Now, suppose you ran into this beast in a dark alley. I'm going to do a fairly straightforward one. Eventually, the x to the 4th part is going to go away, isn't it?
Yeah.
Wouldn't it be cool if there was a fancy way to do this quickly? Besides the calculator. There is. Okay, it goes like this, friends. Let's let u be x to the 4th. Okay. Let's start taking some derivatives, shall we? We're going to get 4x cubed, is that right? 12x squared, is that correct? 24x? 24. You with me? Now, just bear with me, see what you think. Let's look at some dv's here. Let's just start integrating. So e to the x. What's the antiderivative of e to the x?
Yeah.
Why are you doing it that way, Mr. Groom? Okay, so watch carefully. Normally, I'd make you do this. I'd make you say this is u and this is du, yes? And this is dv and this is v, correct? Are you with me on this? And what would you do? You would do u times v, correct? Which would be x to the 4th times e to the x. Are you with me? That, in other words, you'd be going on kind of in a diagonal like that, wouldn't you? Yes? And then Tracy, you would do the integral of well, I'm going to write this. I'm going to write this way, okay? Don't get mad. I'm just going to write this way. I'm not saying you will. I'm just saying, okay? You'd write like that, wouldn't you? Yes? And then who would your u be, friend? Would not this be my new u? Right? This guy right here would be my new u, wouldn't it? So what would you do? Take the derivative again. Am I right? And this, you take the integral again. Of course, you get e to the x again, whatever. So then this would become minus, parentheses, like this, yes? And it would be this fella times this guy. 4x cubed, e to the x, right? Minus, now it's the integral of who? Well, of 12x squared, e to the x, right? Right? But if you distribute that, what happens to our negative sign? Well, it becomes minus, and then it becomes what? Positive. Are you with me on this? Okay. So it turns out there is a cute trick for this that I learned probably 15, 20 years ago from a friend of mine I used to teach here, because he's quite a bit older than me. He showed me this. I'm like, that is the coolest freaking thing ever. So here's the game. When you have an integration by parts problem, which we clearly do, where one of them is going to go away, which we clearly have, make that our u, and it's not a surprise. It's an algebraic function, and algebraic functions come before e, so that makes sense. Derivatate until it gets to a constant. Take the other one and integrate and keep going. Notice how you have one extra on this one, yes? So here it's going to be u times v, another u times v, but this one's going to end up being negative. The next one is u times v, and it's going to end up being positive, because you see right here it changed signs, yes? The next one's going to end up being negative, and then positive. And so you mean to tell me, Mr. Green, my answer is literally x to the 4th e to the x minus 4x cubed e to the x plus 12x squared e to the x plus minus, stupid, 24x e to the x plus 24 e to the x plus c. That's literally your answer. You're done. This is what is referred to as the tabular method. I think it's kind of cool when you have a nasty one like this. I mean, it's not bad, but it's x to the 4th. Do I want to do that 27 times? I do not. Or 5 times. I don't. Just want to be done. Well, normally they're really boring functions. I mean, there's something like, I don't know, 6x to the 5th or something, whatever, times sine of x. Yeah, why not? I guess. Let's do this one. Whatever. Again, this dude's going to go away. Eventually. Mr. Graham, should I pull the 6 out front right now? If you want to, you can. Just remember when you're done, times your whole answer by 6. Are you with me? But I'm going to leave it in, I think, just for fun. Okay? So let's just make a column of u's. So 6x to the 5th. What's the next one? 30x to the 4. 120x cubicled. 360x squared. 720x and 720. Right? Just keep taking derivatives. Right? By the way, if I had pulled the 6 out, this would have been a 1, a 5, a 20, a 60, a 120. I guess an 120. They'd all been 6 times smaller. Yes. All right. But you do you. We're not going to judge. I don't judge. Sine the derivative of negative cosine. There you go. And from whence did negative cosine come? There we go. And from where did negative sine come? Regular old cosine and regular old sine. And it's the same pattern, Mr. Groom. I know. I can't count. Is that enough or do you need one more? One more. Right?
Yeah.
And so I simply draw my lines. They're kind of diagonal lines, yes? They're supposed to be diagonal. And every other one is a negative. Are you with me? And so my answer is simply negative 6x to the 5th cosine x. And then it's minus and minus, so plus 30x to the 4 sine x. And then plus 120x cubed cosine x. Minus 360x squared sine x. Minus 720x. Or 720, I mean what? X, I mean cosine x. And then plus 720 sine x plus c. You'd have gotten that same thing except like 1, 5, 20, and so forth, right? And then you'd multiply by 6 when you're done, yes? By the way, what's 6 times a constant? It's a constant. 6 times a constant is just x to the 4th. Oh, I'm sorry, x to the 4th plus c. Then times e to the x, you mean?
Yeah, something like that.
And this was like a 5?
Yeah.
Well, it wouldn't make any difference. What's the derivative of this?
Okay, yeah, I see the first one.
And what if this was 5x? Well, then it's basically the same thing, but you would, in essence, you could do it a couple ways. You could do it that way, but you could also distribute, right? And then integrate each piece individually, yes? Or you could use the whole use business, okay? Yeah, whichever, man. It's all good. By the way, is this an algebraic function right here? I feel like it is. So, yeah. Would it work? Yeah. Let that be you? Yeah, should. Let's try it. So, that's a good question. Let's try it here. So, let's go u equal x to the 4 plus 5x. du, of course, is 4x cubed plus 5. That works. Cool. dv is e to the x. v is e to the x. Sweet. So, x to the 4 plus 5x e to the x minus the integral of 4x cubed plus 5 e to the x. Which means that this is now my new u, yes? I don't hear any yeses. Yeah, there. Yes, Mr. Grom. And then, of course, this is e to the x, and v is e to the x. There's a dx. So, check this out right here. If you distribute the negative through, right? As promised, what happened here? This first one becomes a negative, right? The next one's going to become positive, and so forth. Yes? But listen, could I have used the tabular method on this guy? Yeah, I think I could, right? Because look, what was my du became my u, didn't it? Right? And so if I keep going here, let's see what we know what's going to happen. So let's just try this again because it's what I do. I can. Where, sir? Oh, thank you, sir. Thank you. Well done, sir. Well done. I got too busy yabbering. Alright, so I just rewrote them. So now we can go ahead and fill this in. Again, the first ones don't matter. They don't touch them. Again, Trace, I'm going to write them like that with this bracket. Ah! Yeah, we're almost home, right? Fortunately, we're getting there. This is a 1 right here. So in this particular case, the parentheses can just be dropped. And u is 24x. Goodness, I'm using a lot of paper. Okay, watch me distribute the negative. Whee! Now what is the integral of 24 e to the x? Why, it's 24 e to the x plus c. Done. If you look at that, right, there's a lot to take in there, yes? But it's not really that difficult, right? The difference is that you have your u is quadratic, is x to the whatever plus whatever x. That's fine. You could have done it in 2 pieces. And if you'd done it as that 5x e to the x separately, and the other piece here separately, you could put them back together, and this is what you'd get. If you distributed all this crap out and wrote it out, they would look identical as the other one. Okay? Last one we're going to do today, I think, and then we're going to have some time to work so you can ask me questions. And what I mean by work, I don't mean diddle around on your phones and piddle around and check out the latest Pinterests and so forth. Work! I want to help. Now, Mr. Grimm, how are we going to do this one? It's a great, fabulous question. Now, let me answer this question. Let me ask this question. When you see an ln, who should it be, u or dv?
You.
U. Because it's a log. What is du then, friends? 1 over x dx. That's hot. What would dv be then? Well, bro, if this is u, what's dv have to be? That's right. What is the antiderivative of that?
X.
Yeah! Ah! So then, by parts, it's going to be x times ln of x, yes, right? Right? uv, right? Minus the integral of v times du, right? What happens to my... Oh, sorry. That should be a dx. Sorry about that. Sorry, my bad. My bad. My bad. My bad. What happens to the x times 1 over x? It's just 1. What's the antiderivative of dx? X. Ta-da! That, my friend, is the antiderivative of ln of x. That's not very difficult, is it? No. Could you prove it's right, Mr. Groom? Probably. Would you like me to try? Hey, this is a product rule, isn't it? What's the derivative of x? 1 times ln of x plus the first, which is x, times 1 over x, yes? Right? Minus, what's the derivative of x? Well, what is x times 1 over x? Well, how about that? ln of x plus 1 minus 1 is just ln of x. And the crowd goes wild. Ah!